Okay, so here we have question B2. So that is section B. So the question reads, the electronic configuration of element J is 2, 8, 18, and then 18 we have 1. J is not the actual chemical symbol of an element on the periodic table, in which Roman numeral 1 group of the periodic table, okay, of the periodic table is element J found. Explain your answer. So that is question 1. So in this case, you have been given the electronic configuration of this element J, and they have emphasized that J is not the actual chemical symbol of an element on the periodic table. So it is just representing the certain chemical symbol of an element on the periodic table. So now question 1, they have asked that in which group of the periodic table is element J found? So how are you going to determine the group in which this element J found? So in this case, if you learned about electron configuration, we know that the electrons in the outermost shell determines the group number of that element. So that is one of the key statements that you should take note of. So in each and every electron configuration that you have on of any element, just know that the electrons in the outermost shell, those we call them valence electrons, they actually determine the group number of that element. So in this case, you check how many electrons, we mean how many electronic shells do we have in this case. We have 1, 2, 3, 4, 5. So the last one, the last shell has 1 electron. So since this one, it has 1 electron, what does it simply mean? It simply means this element J belongs to group 1. All those elements which have 1 electron in the outermost shell simply mean they belong to group 1. I'm repeating, all those elements which have 1 valence electron in the outermost shell, that last shell, it simply means they belong to group 1. Those which belongs to group 2, they have 2 electrons in the outermost shell. Those that belongs to group 3, they also have 3 electrons in the outermost shell. So the electrons in the outermost shell determines the group number of that element. So since it has 1 electron in the outermost shell, it simply means it belongs to group 1. So here we have the answer is group 1. Okay, that's what we have, group 1. So now they have even asked us to explain. So I think I've even already given an explanation to say because, so the reason, okay, reason because it has 1 valence electron. So due to space you finish. So reason because it has 1 valence electron in the outermost shell, hence its group number is 1. Then in which period of the periodic table is element J found? Explain your answer. So how do we determine the period of any element? So again here we only have with the electron configuration. So how to determine the period of any element? We consider the number of shells an element has. So in this case, this element J has how many number of shells? So we have 1, 2, 3, 4, 5. 5 shells. So the period number of any element on the periodic table is determined by the number of shells an element has. So in this case, it has 5 shells. So what does it mean? Simply mean it belongs to period 5. So in this case, period 5. So it belongs to period 5. Reason because it has 5 shells. Okay, because it has 5 shells, it has the number of 5 shells. So of which we know that the period number is determined by the number of shells of that specific element. Okay, name an element in group 6 which is in the same period as element J. So when you go on the periodic table, you check group 6 there. So group 6, that's where we have oxygen there coming down. So you check. We have concluded that in the previous answer we said this element belongs to period 5. So now they want us to find another element which is in group 6, yet it is in the same period as this element J. So when you go and check on the periodic table, you find that there it is tellurium, okay, symbolized by capital T, then small e. So tellurium is actually an element which is found in the same period as the element J that were given. So that is the key important